All right, hey, what's up? It's Coach Hyde, HydeScience.org, physical science resource, working on specific heat. This is the second part in the series. In this series, or this video here, we're going to be working on solving for the mass and the specific heat. So we got our formula. There's four variable spots in our formula. We got Q, right, which is for energy or heat. It's measured in joules. We got the mass, right, measured in grams. You should be very familiar with that by now. We got the specific heat. This is joules per gram degree Celsius as our definition for it. And then we got the change in temperature as well. So 1, 2, 3, 4 spots for our variables. And we should be able to solve for any one of them as long as we have three numerical values to go in the other spots for the variable. So what I wanted to talk to, or what I want to do right now is if we're trying to solve for M or C is our focus right now. And you're going to do them very, very similar. I mean, almost the exact same way. Let's say that we're trying to find the mass. All right, so here's our equal sign. There's two sides to this equation. We got this side over here, right, and we got this side here. Right. We need the mass to be isolated on one of those sides. Similar to how Q is isolated right now, there's nothing on this side with it. We need mass to be the same way. So we need to try to move specific heat and change in temperature. All right, so our rule is if we're going to move part of the formula, we're going to do the opposite action or the inverse action of what is already there. So to move the C, right, we have multiplication currently, right? This is mass times specific heat. So to move that, we're going to divide by specific heat. So I'm going to divide this entire side, that entire side by C. All right. Whatever I do over here to this side, I must do to this side. And it could be anything, right? I can multiply this side by a smiley face. That's fine. I just got to multiply this side by a smiley face too, and we're good. All right, so now that I've done both sides, all right, let's take a look at what we got. Here we have a C, specific heat in the numerator, specific heat in the denominator. We have two things above each other that are the same. They cancel out to be one, right, which is not going to affect our equation. So this is no longer here on this side, right? So we have moved it. Essentially, we can do this, right? That has gone. It is over here now, right? But mass is still not alone. So what can we do? Now let's move the temperature. So now we have mass times change in temperature. All right, we're going to do the opposite of what's there. Right, multiplication is here. So the opposite of multiplication is division. So we're going to divide by the change in temperature. Whatever we do to this side, we do it here. It does not matter if I can put it here, right? Or I can put it here, right? The important thing is it goes into the denominator because we are dividing by that. So we got to put it over here in division. And then we have multiplication between these two, and it doesn't matter the order of that. That's why you can put it at either spot. So that has canceled this because we have the same on top as we do on the bottom. So we have gotten rid of this on this side. We have moved it over here to the other side. Now our mass is by itself. Now we have, you can write it either way. I usually start with my variable. We got mass equals Q, energy, divided by, you see that? Change in temperature times C. Now all we got to do is plug in numerical values for this and solve for mass. Right. If we were doing the same thing, but for specific heat. So we'd start Q equals mcΔT. All right, so now if I'm trying to solve for specific heat, I'm going to do the same thing. Right? I need to get C by itself. So here's my equal sign. I need C to be isolated on one of those sides of the equal sign. So I can move the M or I can move the change of temperature. It doesn't matter which one I do first. Right, multiplication doesn't matter the order. However you want to do it. I usually go left to right. That's kind of how you read a book. Left to right, top to bottom. It's good to go for math too. So here we have M times C. I'm going to do the opposite of that, which is I'm going to divide this entire side by M. And I'm going to do the same thing to this entire side over here. I'm going to divide it by M. This cancels the M. Right? When I say cancel, we can basically say it's gone. All right? Now C is still there. So we need to move the change of temperature. Again, this is C times change of temperature, so we're going to divide by the change of temperature. right? We're going to put that over here. So we have removed the change in temperature. So now we have C equals Q divided by change in temperature times M. So C equals Q divided by change in temperature times mass. So we have rearranged our original formula. Q equals M times C times delta T. Energy equals mass times specific heat times change in temperature. We have rearranged this algebraically so that we can solve for mass or we can solve for C. As you saw, it's basically the same process. So let's see, we're going to use the same numbers we used in the other one. I don't remember what they are. Let's see what we got. All right, so if we were solving for mass, all right, and we were given the following: 8,000 joules. What was it? 4 joules per gram degrees Celsius, and 10 degrees Celsius is our change in temperature. All right, so we could use these numbers to solve for mass. All right, using this formula. So we're going to set it up. M equals, right? Our Q is going to go on the top. So let's plug it in here. Our Q is 8,000 joules because we see that J, right? We know it stands for heat or energy added. So 8,000 joules. Our change in temperature is 10 degrees Celsius. And our specific heat, C, is 4. All right. What I said in the last video, what I talked about last video, was when we see this per sign right here, this division, okay, we're going to write it like this. What happens though, right? What happens when you get this? You can't have division within the denominator of the division thing, right? So this kind of flips back up to the top when we divide that. So we kind of take this and we put it up here, right? Now you don't have to do that as far as canceling units out. I mean, you could have the third row down here, right? That's kind of how we do it, just to keep things simple. But realize it goes to the top technically. So we're going to work this out. All right. Marker here. First thing I like to do is, can we cancel out any units? So I have a gram down here in the third row. I do not see any other grams, so I cannot get rid of that gram. I have a Celsius, Celsius, joules, joules. So whatever my answer is going to be, it's going to be in grams, which is good because I know mass needs to be in grams. That means I'm on the right track. Now I also see this 0 here and a 0 there. So I can get rid of those zeros and make the numbers smaller, which smaller is easier, right? Deal with. So then kind of work out what I got. So now I got 800 on top. I got 1 times 4 on bottom. Right? Also got grams down here on the bottom. 800 divided by 4. 8 divided by 4 is 2. This is 0, 200 grams. All right. So there we have successfully solved for the mass. We can also use this, or I'm also going to do an example of solving for specific heat. It's the same thing. It does the same way, right? So now let's say we don't know what the specific heat is. We know that, so we don't know the specific heat is that, but we know the mass is 200 grams. We should be able to solve this for specific heat. What was it, 4? It should be 4 at the end. Let's see what we come up with. So we're going to have C equals 8,000 joules divided by temperature, 10 degrees Celsius, divided by mass, 200 grams. Okay. Again, first thing we should do, kind of a habit. Let's see if anything cancels out. See if we can make our life easier. Degrees Celsius, grams, joules. No units cancel out. There's nothing on the same on top and bottom. So no units cancel out. So whatever my answer is going to be joules divided by grams degrees Celsius. But check this out. 0, 0, 0, 0, 0, 8 divided by 1 times 2, 4. So my answer is 4 joules per gram degree Celsius, which is what it should have been. Again, so here in this video we have learned how to rearrange this equation, our specific heat equation, rearrange it for mass, right, by moving the variables, doing the opposite, and then we only cancel out, what's the other one? That's it, really. Do the opposite action, whatever you do to one side, you do to the other side, and you just keep doing that, keep doing that, keep doing that until you end up with your variable isolated. All right, so we did it once for mass, once for specific heat. Once you get to this point, it's just a matter of plugging in numbers, canceling out units, making things easy for yourself, and solving it. So this is the second video in the series. We have the first one, solving for Q. This one is M and C. Next one is on change in temperature. Now that's going to be pretty much the exact same video, but I'm going to do a separate video because sometimes you got to solve for the change of temperature and then add that to the original temperature or take that away from the original temperature or something. I just might be a little extra step or two in there, so we're going to do a separate video on that. If you need anything, request the video, see what I can do about it. Till next time.